Okay, this is lesson 4.5, and in lesson 4.5 we look at the last form of a quadratic relation. We're going to continue exploring all these forms, and we've spent the most time looking at vertex form. The first lesson looked at something called standard form, which is where we had our ax squared plus bx plus c. The majority of the unit, what we just finished, was looking at vertex form. That was with our transformations. And our last form is going to be looking at this form. This form is called factored form. And in factored form, instead of having an ax squared term, or that bracket with the squared on the outside, we have two brackets. We have an a, and then we have an x minus something, and then we have another bracket, and then we have an x minus something else. The a represents exactly what you think it would represent. It's the stretch or compression or reflection factor. It's the same as the a in every single form of a quadratic. The a doesn't change. It means the same thing in every form. The r and the s are the things that are new. Vertex form told us the vertex. Standard form gave us the y-intercept. That c was the y-intercept. There's one other feature of the graph that isn't represented in a form, and that's the x-intercepts. The x-intercepts are represented in factored form. The numbers that represent the r and the s in this equation are the x-intercepts. So if we look at this example here, we have an x-intercept of -2 and an x-intercept of 5. My r would be -2, and my s would be 5. So if I wanted to start writing an equation, I don't know what a is yet, but we know x minus r, x subtract -2 would be plus 2, and x minus 5. That's how the brackets would look. They're the same numbers with the opposite sign, much like h in vertex form. Remember, h always had the opposite sign on the graph and in the equation, the vertex in the equation. Same with r and s. So we get our r and our s from the x-intercepts. And then we can use another point like the y-intercept to figure out what a is. And that's how we can come up with an equation. That's how an equation is related to a graph. So we're going to look at two examples. We're going to start with an equation and we're going to use the features to come up with a graph. Or the second part of the video is going to be taking a graph and coming up with the equation. And then that's pretty much it for the unit. We don't really need to understand how to switch between forms. That's actually the whole next unit. All we need to do at this point is understand that we have 3 different forms of a quadratic, how to get a graph from each, and how to write the equation from each. Except for writing the equation from standard form. I'm not going to ask you to do that. But definitely from factored form and definitely from vertex form. So let's look at an example. To come up with the graph from an equation of factored form, we first need to identify that it is factored form. Factored form is the form where there's 2 brackets. So if you have a form where there's 2 brackets, it's factored form. A, x minus r, x minus s. So, steps for graphing. Step 1, identify and graph the x-intercepts. Well, for all the ones we're going to do in this unit, the x-intercepts are just going to be the numbers from the bracket with the opposite sign. So if we take out what a is 2. R would be the opposite sign, so -1, and s would be the opposite sign, so 3. R gives us an x-intercept, and s gives us an x-intercept. Our first x-intercept is -1, 0, and our second x-intercept is 3, 0. So now, from this equation, opposite signs, we have 2 x-intercepts. So let's graph them. negative 1, 0, and 3, 0. Step 2. Find the axis of symmetry. Now, why do we want the axis of symmetry? Well, we want the axis of symmetry because that's where the vertex is going to be. The vertex is going to be on the axis of symmetry. We don't know where, but somewhere. Somewhere between these 2 points. In fact, if these points are symmetrical around the axis, which x-intercepts are, the axis of symmetry will be right in the middle. And sometimes you can just count it off and it's pretty easy to figure out the middle. Go 1 over, and then go 1 more over. We meet here on this line 1. Our axis of symmetry is right here. It's in the middle of the x-intercepts. I can show you the math. The math says if you want the x-axis of symmetry, you take r and you add s and you divide by 2. You find the middle. R is negative 1, s is 3, divided by 2. Negative 1 plus 3 is 2, divided by 2 is 1. There's your axis of symmetry. So we got our x-intercepts from our first step, axis of symmetry from our second step. Step 3, find the vertex. And the way we find the vertex is we plug in the axis of symmetry. And the reason why is because, well, the vertex is going to be on the axis of symmetry. So we know the x of the vertex. The equation is x plus 1, x minus 3 with a 2 in front. Axis of symmetry is 1, so we're going to plug it in. 2, 1 plus 1, 1 minus 3. Let's do a little math. 1 plus 1 is 2, 1 minus 3 is negative 2. We've got 2 times 2 is 4, times negative 2 is negative 8. There's the y. So we can now say, therefore, the vertex is 1, negative 8. And now we just have to graph, oh, couldn't see that. And now we just have to graph 1, negative 8. And now we have enough points to come up with a parabola. We can just connect these 3 points and extend them a little bit, and that's a parabola. Now, not entirely necessary, but if you want a few more points, you can use the step pattern. If you remember the step pattern, the step pattern is usually 1, 3, 5, but our a value is 2. So our step should be twice as big. 2, 6, 10. So now that we know the vertex, we can go over 1, up 2, and that would give us another point. Over 1, up 2, another point. Over 1, up 6, looks like it should take us to our vertex, or our x-intercepts, and it does. Over 1, up 6 takes us to our other one. Last step is 10. Over 1, up 10 takes us to the top of the graph. Over 1, up 10 takes us to the top of the graph. Do we need all these extra points? No, we don't. But that's how you can use everything we've learned this unit, put it together, and get a more accurate picture of our graph. I need you to be able to plot the x-intercepts, find the axis of symmetry, plot the x-intercepts, find the axis of symmetry, use it to get the vertex, and then connect your 3 dots. But, to review, now we have every feature on this graph. We started with the x-intercepts. One of them is 3, 0, and the other one is negative 1, 0. We have the y-intercept is 0, negative 6. We have a vertex which is 1, -8, and we have our axis. That's every feature of a parabola, all on our parabola. I can tell you this is definitely going to be a question on your unit test. So what I would suggest is practicing graphing using these 3 steps, identifying that when you have 2 brackets, identifying that when you have 2 brackets in your equation, that it's factored form, and factored form tells you the x-intercepts. You can use the x-intercepts by adding them and dividing by 2 to find the axis of symmetry. You can plug in the axis of symmetry to the equation to find the maximum or minimum value, which gives you your vertex. And if you need to, you can use the step pattern to kind of round out your parabola and get more points. And that's how we can graph from standard form. Sorry, that's how we can graph from factored form. Our last question is going to show you how you can come up with the equation from a graph. By Lake Ontario, there is a gate that is 20 meters tall and 22 meters wide. Sketch a graph of the gate with the left post of the gate located 4 units left of the y-axis, and label the x-intercepts and the vertex. All right, we don't have a grid, or we don't have axes on here, so I'm going to go 2 blocks up from the bottom and draw my x-axis, because our gate probably isn't going to go underground, and our x-axis is going to represent the ground. And since we need to go 4 units to the left of the y-axis, I better go over 4. 1, 2, 3, 4, and go right to here. And that's going to be our y-axis. And what's neat is I made this grid perfectly to fit this. So if you trust me here, let's get some points on this graph. The left post of the gate is going to be 4 units to the left of the y-axis. That's going to be right here. There's our left post. Our left post is -4, 0. And obviously the post is on the ground. Now, that's an x-intercept. Our gate is 22 meters wide. So if I count 22 blocks, the first 4 gets me back to 0, and the next 18 blocks would get me to 22. So that point is 18, 0. And that's 22 meters wide. 4 to the left and 18 to the right. Together is 22 meters. Now the maximum is going to be 20 meters. And if we count these boxes, there's actually 20 all the way to the top. Where is that maximum going to happen? Well, it's going to be right in the middle of -4 and 18. It's going to be on the axis of symmetry. And if you remember, to find the axis of symmetry, you take your 2 x-intercepts, you add them, and you divide by 2. -4 plus 18 is 14, divided by 2 is 7. The axis of symmetry is at 7. And it said that the gate's 20 meters tall. That's going to be the maximum. So we know our vertex. Our vertex is going to be the x from the axis of symmetry and the maximum and minimum value. So let's count over 7. 1, 2, 3, 4, 5, 6. Hold on. 1, 2, 3, 4, 5, 6, 7. 7 all the way up to 20. There's our vertex. 7, 20. And that's about as much as we need. We're going to connect these and we're going to come up with our picture. And there's our gate. Might as well get the axis of symmetry on there. We got everything else. Now we can use all of these features to come up with an equation. Well, how do we do it? Well, let's write some steps and then we'll follow along with the steps. Steps. If we wanted to do one in vertex form, we could because we know the vertex. But since this is the lesson about factored form, step 1, write factored form equation. And the factored form equation is y equals a x minus r x minus s. Step 2, plug in x-intercepts for r and s. Well, our x-intercepts are -4 and 18. So we're going to plug in -4, x minus -4 would be like +4, and x minus s would be like -18. Remember, opposite signs. Step 3, plug in a point, an x and a y. Well, the only other point we have, because we can't use one of the x-intercepts, is our vertex. Our vertex is 20 and 7. There's 2 x's, so we put in 7 twice. Once we've plugged in our point, we solve for a. How do we solve for a? Well, we got to do a little bit of math in our brackets. 7 plus 4 is 11. 7 minus 18 is -11. And now we've got a times 11 times -11. We can do the math. 11 times -11 is -121. And if we want to get rid of this -121, we can't add it because it's being multiplied by a. So we have to divide it away. (20) divided by -121. Well, that's a very ugly decimal, so I'm just going to keep it as a fraction. And there we have a. So for step 5, rewrite equation with a, r, and s filled in. So our last step, y equals a, -20 over 121, x plus 4, x minus 18. If you wanted to turn that into a decimal, that would be okay. Sorry, it's negative. It's better if we keep it as a fraction because the decimal is not super exciting. We'd have to round it. We don't want to round. And there you have it. There's your steps for determining the equation from a picture of a parabola. And that's it for Unit 4. Thanks for watching, and I'll see you in Unit 5.